No more bell ringers. So we're going to get straight into the lesson. So we're going to describe distributions, which means we're going to look at the shape. So is there a cluster? Are there gaps? We're going to look at the distributions, meaning what are the ranges, what are the interquartile range, and we're going to use those shapes, the measure of center and variability, to draw conclusions. So which one of those is going to be the better to use? So that's what we're going to do. All right, so it says a veterinarian monitored 18 pregnant cats. The number of kittens per litter is summarized in the table.
There's baby kittens.
Yes.
I think kittens are very adorable, but I don't want one.
All right, so I'm going to go ahead and do the dot plot first so that we can...
You can't share your screen, can you?
Oh, yeah, I can. I thought I had already done it. My bad. Oh, wrong thing.
Yeah, Miss Lavelle, I can see that you're planning a meeting or something.
Yeah, I hit the wrong one.
Miss Lavelle? Oh, I'm sorry I'm late. I had to go to the bathroom.
Okay.
I cannot believe it.
All right, so here we go. All right, so the litter size of 1 happened 1 time. So we're going to put a dot at 1. The litter size of 2 happened 3 times. The litter size of 3 kittens happened. Wait, I missed it. Sorry, I put it in the wrong spot. 2 should have 3, right? Okay, 3 kittens should have 4. 4 kittens should have 3. 5 kittens should have 3. 6 kittens should have 2. 7 kittens would have 1. 8 would be 0, so we can't put anything, right? And then 9 kittens would be 1. All right, so the statistical question that we are asking is how many kittens are in each litter? Guy, can you imagine having 9 kittens? That's a big litter of cats. All right, so it says, I know, that's a lot of kittens. All right, so it says, since the table shows exact data values, well, we already know because we did it, right? A dot plot would be the best choice to display the data. All right, so how can we describe this data?
We could describe it by the shape.
Yep, so talk about the clusters and your peaks.
And by the way, Miss Lavelle, so I was doing one of my assignments on Into Math, and it just turned it in. While I was trying to do my work.
Okay, well, you'll have to send me an email and let me know which one it is I need to reset. All right, so
it's the last time.
You need to send me an email so I can remember. I will not remember. Okay?
Okay.
All right.
Please don't count me as late. I think it's the 16.4 OIO.
Okay. Once again, I have too much going on during the day to remember. Send me an email. All right, so is it symmetrical?
It doesn't look symmetrical.
So, nope, not.
The peak is 3.
Okay, so not symmetrical. The peak is at 3. Do we have any gaps?
7 and 9.
Yep, between 7 and 9. Okay, can we find the range?
What is the range again?
The difference between the largest and the smallest,
Yes, we can.
which is 8. All right, so that's the only thing we can do to describe this. It's not symmetrical. We have a peak at 3. We have a gap, and then our range is at 8. All right, so we need to find the mean. So that means I have to add 1, 2, 2, 2, 3, 3, and 3. All right, so if I put it in order, that's what we have. Now, what I do sometimes is, since I have so many of each number, at the top I put the value. So like we know that this one's only 1, right? But this one is 2, 4, 6. This one is 3, 6, 9, 12. 4, 8, 12. 5, 10, 15, 12, 7, and 9. So to make it a little bit easier, instead of doing 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3, I just add these numbers up here. So I do 1 plus 6 plus 12 plus 12 plus 15 plus 12 plus 7 plus 9. Okay, so the mean, when I add all those together, I get 74, and we know that they surveyed or looked at 18 cats. So that would be divide by 18. Okay, it does tell me to round to the nearest tenth. So if I do 18 divided into 74,
it says tenths.
so I know it goes 4 times. Put a decimal point, add a 0, bring it down. 18 goes into 21 times. And what do you notice is going to happen?
It's going to be an infinite loop.
Yeah, it's going to repeat, right? It's going to be 1, 1, 1, 1, 1. So we are going to leave it as 14.1. Yep, so the mean is 4.1. 517. The page number is 517.
But Miss Lavelle, you should really start reading Goosebumps.
Okay, thank you, William. Sorry, I got to go back and mark people here that are here. No Nash, right? Okay. All right. So now we need to find the median. So we have 18 data points. So that means I'm going to have 8 on one side and 8 on the other. So 1, 2, 3, 4, 5, 6, 7, 8. So these two would be my middle, and then 1, 2, 3, 4, 5, 6, 7, 8. So this is my middle. So, yeah, so they're both 4, so I really don't need to add them and divide them, right? All right, and the mode, which one occurs the most?
3.
3. All right, so mean, median, and mode. All right, so looking at the shape of the data distribution in the dot plot, which of the measures of center would best represent the data?
5.
So would it be the mean, the median, or the mode? Now think about it, guys. We have an outlier, right?
Yeah, it's 9.
So mean, so we would say not the mean, because of the outlier. So it would either have to be the mode or the median.
I think it would be the mode.
Yep. So the mode is better.
But why
Okay.
can't it be the median?
So I mean, I personally think the median would be just as good, but the book says it's the mode, because if you look what's clustered around the mode, we have 3 here at 2 and we have 3 here at 4, and 3 is my peak, right? So that's why they say it's better, because it is clustered around the mode. So the data is clustered around the mode. So that's why the mode is better.
I'm hungry.
All right, are we good? Can I flip the page?
One sec.
Okay.
Okay, I'm good.
All right, so let's look at this one. So this one is a frequency. Now remember, when we do frequency, we can't do a dot plot because we don't know exact numbers, right? Because they're frequencies. All right, so it says the table shows the distance some students at Valley Middle School live from the shopping mall. So what are we looking at the data? What are we looking for? How what?
How far is the middle school to the shopping mall?
Right.
How far students shop?
So how far students live from the mall.
I like that they have like a picture.
All right.
Maybe a picture of the shopping mall.
Yep.
Makes me wanna go.
All right, so now we're going to graph them. So they did the first two for us. We're going to graph the 4 to 6, and we have 6 people. So remember, guys, in a frequency, it touches the next bar to it. Okay, and at 6 we have 9. At 8 we have 8. At 10 we have 5. And at 12 we have 1.
One sec. got 1. 14.
All right, so describe.
Pencils and markers and stuff. Be right back.
All right, so describe the shape, the center, or where the peak is, right? The range, and the distribution of the data. All right, so is it symmetrical? I would say it's pretty close.
Well, pretty close.
So we're going to say it's symmetrical. Do we have any outliers?
Yeah, no.
So no outliers, right? Because they're all within a range of each other. Do we have any gaps?
No.
Nope. Okay, where's my peak?
6.0138.
Yep, so that's my peak. And then what is my range?
Range is from 14 to 2, which is 12. Oh, 9.
Yeah, so we really kind of don't know the actual point, so it's kind of hard to do the range, but it says range, doesn't it? Does your paper say range? What does your paper say, guys?
It says data by identifying clusters, peaks, gaps, and symmetry.
Okay, so your question actually doesn't have range, because you can't find the range of that. Yeah, I didn't think your paper's a little bit different. All right, so we did the clusters, the gaps, and the peaks. Did we miss anything on your paper?
No, we got symmetrical, no outliers, no gaps, peaks at 6.01.
All right, good. All right, so it says draw one conclusion about the survey based on the fact in part C. So what can we conclude about this information, about this, mainly these three right here? Students live where?
Students live mostly from 6.01 through 8 miles away.
Yep, so students live most of the time between 6.01 and 8. Yep.
But I don't live there.
I know.
I wish I could, though.
Yep. All right, so.
I did students live mostly between 6.01 through 8 miles.
Yes. All right. So, suppose there were 15 students missing from the sample.
15 missing students?
Yep. So 7 live between 2 and 4. So we're going to add 7 people up here. So 7 plus 4 is what?
Is in between, well, if we add that,
It should be 11, right? So that's going to have to go a little bit above 10.
just about at the line.
Yep. And then 3 students live between 4 and 5. So we're going to add 3 to 6, so that would give me 9. And I'm kind of shading it, guys, so you can see the difference. All right, and then the last one 5 students live between 10 and 12. So 5 plus 5 would give me 10, right? All right, so looking at our new frequency table or our histogram, what happened?
A lot of numbers changed.
Yep. So is it still symmetrical?
No.
Yeah. So we're going to put no longer symmetrical.
Different peak and different cluster.
Yep. Different peak. And then now our cluster, well, if you look at it, if this is our peak, I would say now 4 and 6 has become kind of that cluster where it's around, right?
Different cluster.
Yeah, so different cluster. But we still have no gaps, right?
Yes.
All right, so that's what happens.
No. Hey, can you keep this page up longer? Can you zoom out?
Yep. I don't know if I can zoom out far enough, though, to get the table in. We'll see. If I do it like that, maybe?
Yeah.
Okay.
Miss Lavelle,
Yeah.
Sophia's the only one copying it down. Can I tell you a little about
Well, how do you know that she's the only one still copying it down?
I was just making an estimate.
Yeah. So, William, though I like you sharing things with me, some people can't always concentrate when people are talking when they're trying to write.
Okay.
Okay?
Can I tell you after class?
No, because after class I gotta head to lunch. Because we only get 30 minutes and then I gotta watch a different class.
Okay. All I gotta say is it's a good book.
Okay, I'm sure they are, sweetie.
From that inference, I guess you can tell us goosebumps, Lilia.
G, are you done? Are you ready?
No.
Shows the average daily temperature in degrees Fahrenheit for Martha's 8-day family vacation. Okay, so 8 days. Since the table shows distinct data values that have a wide range of values and gaps between the data, a blank is a good choice for the data. So definitely not a dot plot because the dot plot will show those gaps. So it has to be a
Box plot.
Yep, a box plot. All right, so remember with box plots, we have to put the data points in order from least to greatest. Okay, so my first number is 56. $66, $66, $72, $72, $75, $77, and $80. All right, so remember with box plots, we have to find the median of the lower quartile, the median of the upper quartile, the interquartile range, and the range. All right, so we're going to do it step by step. All right, we have 8 values, right? So that means I'm going to have 3 on one side, 3 on the other, and 2 in the middle. but the two in the middle are the same.
So it's 72.
Yep, so my median is 72. Now remember, when we have 2 in the middle, I have to include one of those in the lower quartile.
So the lower quartile is 66.
Yep. And then once again, on the other side, I'm going to include...
77 and 75 is
Yep.
the upper quartile. Wouldn't you have to add 77?
Hey,
Do you have a stand that I can put the
75.
I do not. That's the only thing I don't have a thing for. Get one of, do you have wall space?
What you mean?
Means where you can put it, like, see those little hook things that I have back there?
Yes, ma'am. Yeah, I got wall space.
You know what, hold on a second, guys.
Wouldn't it be
You did everything
76?
by yourself?
Because between
Yeah.
75 and 76.
Just stick them on there and go.
I'm gonna put something together.
Because between 75 and 77, it would be
Some of those,
76.
yeah, here.
Your lifesaver.
Just put this on the wall and it should look right on it.
Yes, ma'am.
You need 2 of them or just 1?
I do 2. That's all right. Thank you, Ms.
Yeah,
Lavelle.
you're right.
Bye.
It would be 76.
I'll be back with the different one for the teachers.
Okay, sorry guys. Alright, so what was the upper quartile again?
76.
Yep.
Because between 55 and 77, it would
Yep.
be 55 and 77, it would be 76.
You are got it. So that would be 76. Oh, I think my pen is dying. All right, so what is the interquartile? Oh, so let's graph it, right? All right, so median is 72. 2, 4, 6, 8. So there are 2, right? So, okay, here's 72. And then 66, 2, 4, 6, 66. And then 76. So 2, 4, 6. I mean, really close. All right, so my largest value is 80. My smallest value is 56, so 2, 4, 6. So that is what your box plot should look like.
80 minus 56 would be our... Wait, no. Yeah, the interquartile range.
Is what?
56 minus 80.
No, the interquartile range are the 2 quartiles. So 76 minus 66.
That's 10.
Yep. And then the range is 80 minus 56.
I got this one.
Which is what?
24.
Yes. All right, so state one conclusion that can be drawn from the shape of the data and the range, and one conclusion that can be drawn from the shape of the data in the interquartile range. All right, look at the range. What does that mean when it's very large?
There's a large amount of clusters.
Okay? It also means that there's probably a what?
Outlier.
An outlier, yeah. All right, so
56.
the outlier causes the range to be larger, but you're right about the IQR. Our points are real close together, right? So the IQR is closer because most of the data is between 66 and 76. So it's pretty close together. All right, so that leads us to the check understanding. Okay? So take about,
A little bit.
I will, take about 5 minutes, guys, and work on that check understanding, okay? And then we'll come back and check it. So for these, they're looking for range, IQR. Is it symmetrical? Are there gaps? That's what they're looking for. Okay?
4 seconds.
So, what is the range of this?
75. Because it's 95 minus 1.
Yes, so what is the IQR?
40. Because it's 70 minus 30.
All right, so can we make any assumptions?
Hmm?
Can we make any assumptions?
Definition. Guesses. Oh. About what?
So if this is my median, right? There's a lot of data points between here and here, right? "95 could also be an outlier. We don't know. And then the median, we know, is 65, right? So by looking at my box, from 65 lower, that data's pretty spread out. Because you can see that from the box. But when I get here, my data's not spread out on the right side. All right, what about number 2? Is it symmetrical?
No.
I would say it's kinda. I mean, it's pretty close.
It's 9, so you'd have to do it in between 4 and 5, but it is not because just try to fold it.
All right, what's the peak?
Peak is 5.
Okay, what are my gaps? Bless you.
0 through 3 and 6 through 9.
Yep. Do we have any outliers?
Yes, 9.
What else?
The cluster is 3 through 6. And the lower quartile is 0.
What is my other outlier?
0.
Yeah, this isn't the lower quartile. The lower quartile would be the median of the data on the left. But yes, your least value is 0, and the greatest
No more space.
value is 9, even though it didn't ask you for the least and the greatest, right? Some of you may have done the range. The range is also 9, okay? So they didn't ask for all that, but that's just some of the stuff that we put. All right, guys, so that is it for today. I will hopefully see you guys either outside tomorrow or sometime next week, okay? Remember, check your daily agenda because it will change on a day-to-day basis depending on testing and who shows up and who doesn't.
Wait a minute. There are 3 parts of this test. Your math test.
Correct.
So, are we supposed to do like 2 parts one day and 1 part another?
Yes. So you will have 2 maths on one day and 1 on the other. I don't know which is which though. Who is that? Brianna? Or is that Peyton? Peyton.
Bye.
Bye.
Have a nice day. Do we have to do that on your own?
You will, but it'll be someday next week.
Okay. Thank you.
All right. Y'all have a good night.